Thank you very much for your interest in this talk. I've never expected the room so full crowded. My name is Moritz Halbritter. I work in the Spring engineering team. I primarily work on Spring Boot and started Spring.io. There are a lot of stuff on this slides. Don't worry, you can download them afterwards. There is a QR code at the end, so you don't have to take pictures, stuff like that. There is also very much text on the slides because you can use them as a reference when you do your upgrade yourself, okay? But the most important stuff is happening on the audio track, so you don't need to read all that stuff. The first thing to know is Spring Boot 3.5 is supported. It came out in 2025 and it's supported until like June of 2026, which is in like 2 months. Okay, so you either buy enterprise support or you have to upgrade in 2 months. Otherwise, you're falling out of the open source support. Not sure if you realize, but that's how it is. Okay, let's quickly talk about the requirements. Jürgen in his keynote already iterated on them, so I'm going to skip over quickly. The baseline is still Java 17, so we haven't upped the change line, but we strongly recommend Java 25. And we pull in, so Spring Boot 4 pulls in Spring Framework 7, and Spring Framework 7 pulls in all this stuff, like JUnit 6, GraalVM 25, and other stuff. But this has all been covered in the keynote already. Okay. Stuff we removed. Everyone likes to remove features, especially if you use them. Undertow support is gone. Not sure if you've noticed. We had to remove the Undertow web server. So we have like 4 supported web servers in Boot: Netty, Chetty, Tomcat, and Undertow is gone. The problem is Undertow has no Servlet 6.1 release yet. Okay. We removed support for Undertow, and as it stands, we are not going to put it back. The migration part is use Tomcat or use Chetty. And this is from our issue tracker. So we had a conversation with one person who was not happy with the memory consumption of Chetty and Tomcat, and we fixed it, and now this person is happy, and I hope so do you when you're using Undertow now and upgrade to Tomcat or Chetty. Other removed features. We removed Pulsar Reactive. Not sure if you've ever heard of it. It wasn't that popular. Okay, that's good. We also removed embedded executable Uber jar launch scripts, which is a very cool name and a very wacky concept. So you essentially could execute directly on the shell your jar file without prepending java-jar. Super weird feature. Not sure if anyone has used it. I'm really glad that it's gone because it was a huge hack. It's gone now. We removed Spock. So if you use Spock for testing, yeah, it's gone in 4.0, but it's back in 4.1. Okay, so we had problems with the Groovy update. It didn't came in time, and in 4.1 Spock is back. So don't shed tears. You can still test with Spock. We also transferred stuff out of the Spring team to other teams. For example, Spring Session Hazelcast is now maintained by the Hazelcast team itself, and Spring Session MongoDB is now maintained by the Spring MongoDB by the MongoDB team. Okay, let's talk about the elephant in the room because this is the stuff which likely will affect you the most. What we did is we hacked up the Spring Boot autoconfigure. So Spring Boot is essentially an embedded web server, something which binds configuration properties to Java classes, and then a lot of auto-configuration. And auto-configuration works by looking at your class path, seeing what's on there, and then it configures the Spring context. This is the magic behind Spring Boot. So when you put something on the class path, stuff starts configuring yourself, and you are happy because you don't have to write boilerplate. Every auto-configuration we had for all the technologies, Kafka and Flyway and Redis and everything was inside this jar. Okay, this was a 2.1 megabyte jar with all the auto-configurations, also all the auto-configurations in it. What we did is we split it up. We extracted several smaller modules, okay? So there is now one for Spring Boot Actuator, there's now one for WebMVC, and so on and so on. So every technology now has their own small module, okay? And by doing that, we also realized that we have to split up Spring Boot test autoconfigure, because this whole autoconfigure thingy is also mirrored for tests. Yeah? Like there's WebMVC tests and stuff. Why? Why would you do that, Moritz? Why would you force that on us? The first thing is it enables some cool features. For example, better signal for auto-configuration. So in the past, if you want to use a web client, you had to put webflux on the class path, right? Spring webflux. And Spring Boot has no way to know if you put webflux on the class path because you want to essentially have add controller support in a reactive web server, or if you just want to use the web client. So what we did is we configured reactive web server support, which may not be what you want. Now, you could put the web client module on the class path, you only get the web client, and if you want to have like real webflux support for reactive controllers, you put the webflux module in the class path. So we now have a much better signal what's actually on the class path and what we should configure. It also enables new features. For example, if you think about metrics and tracing, they have been coupled to the Spring Boot actuator. So if you wanted metrics or if you wanted tracing, you always had to get actuator on the class path, because the auto configuration for metrics and tracing was in Spring Boot actuator auto configure. Okay? Now it has a separate module. So now you can do metrics or tracing without actuator, which is sometimes interesting. It also gives you a much better developer experience, because if you autocomplete in your IDE with control space, then you get all kinds of classes, because your IDE has indexed this big 2 megabyte Spring autoconfigure module, and there is all kinds of stuff in it. And then you have like a Kafka customizer and some other customizer stuff, which you don't care about because you maybe don't use Kafka. Okay? Now you have like less classes in the autocompletion because you only have this stuff on the class path which you're actually using. The same for properties. If you hit like control space in a 3.5 application, IntelliJ or Eclipse or whatever will suggest you like all the properties which are there in Spring Boot, even if they have like no relation to your application, because maybe you have properties for Redis in there. You may do not have Redis on your application. Why is there a property for Redis if I don't use it? Right? Now there are only the properties inside the autocompletion which you actually use, because the IDE now indexes smaller modules, and there is only stuff on the class path which you actually use. And there are also slightly smaller jars for you, because instead of this big autoconfigure thingy, which is always on the class path, you now have like smaller modules on the class path. Okay, so and your jars will get smaller because you only include what you need. Let's look at PetClinic 3.5. This is like 65 megabytes total. And here I filtered on the Spring Boot autoconfigure. Here's the Spring Boot autoconfigure thingy, 2 megabytes. Then there is the Spring Boot core thingy. Then there's another autoconfigure module, actuator, and some other XAML tools. When you upgrade for something, it looks like this. There are a lot of smaller Spring Boot modules. So the Spring Boot core is still there. It's a bit smaller, but here is the autoconfigure. Previously 2 megabytes, now 371 kilobytes. But there are a lot more of them. But if you sum them up, this here is smaller than this here, and this is still smaller in 3.5 because the other dependencies we pull in, like Hibernate and other stuff, just got bigger. Okay? So we save you some time, but please complain to the other projects that they pollute your stuff. We also did it for ourselves. Okay? We just did it for the stuff I already mentioned, but we also did it to improve the maintainability of the Spring Boot codebase. It all started out by one of our team members had the idea of, why do we have like everything in one module? It's a God module. Everything is in there. Why shouldn't we split it up? And we had that idea for a long time, and every time we said, yeah, no, it's too much work, it's too much work. It was a lot of work, but there are benefits of it. Because now the code base for ourselves is more maintainable, because we now have more isolated changes. So if, for example, if I fix a bug in Redis, we only have to touch the Redis module and not rummage around in the big module. We also have the architecture validated through the build system, because we now have smaller modules, and those modules may depend on each other or not. But now you can't accidentally, for example, put a reference from Kafka to some Reddit class because it's in a totally different module which have no dependencies on the Gradle build system. Of course, we had like Arch unit rules to validate our architecture, but sometimes stuff falls through the cracks, and now it's much safer because like essentially Gradle protects us to do architecture violating stuff. And we also get a much faster build because, so we use Gradle as a build system, and Gradle is like really smart when to execute stuff and when not to execute stuff. So before that, if you touch one class, it doesn't matter which one, in Spring Boot autoconfigure, it has to run all the tests inside the Spring Boot autoconfigure module, and there are a lot of them, and then it takes like 7 minutes and something. Okay? If you do the same thing in one of the modules of Spring Boot 4, your build runs in 33 seconds. Okay? Because Gradle is now here, it has to execute like 1,800 tasks, and here it only executes 400, and this stuff here is cached. Okay? So our build just got much faster if we only do changes in one module. That's no benefit for you, but it's a huge benefit for us. We also improved the starters arrangement, because usually if you use Spring Boot, you don't care about the modules, you care about the starters, because that's the stuff you actually use. If you go to start.spring.io, it puts starters in your dependencies and not modules. And those starters transitively depend on the modules. What we did is every technology now has their own starter. Okay? Before that, there were some starters, some technologies which had no starter. Now every starter has a technology. It's always named Spring Boot Starter and the name of the technology. The package is always org.springframework.boot.technology. This will get interesting when you do the migration, because now if you get a compile error that some class is missing and you know the package, you know in which starter it is. Every starter also has a test starter, okay? And test starters are always called Spring Boot Starter Technology Test. If you find something which doesn't match the pattern, please create a bug tracker issue, because it's a bug. The package is always called org Spring Framework Boot Technology Test, and it contains useful code for testing. For example, add web-MVC test is in the Spring Boot Starter web-MVC test module. Okay? That's the idea. We made everything like the same. Even if the starter is empty. So if we have some starters which have no dedicated test support, there is still a test starter. This test starter does nothing. It only depends on Spring Boot Starter transitively, but we wanted to have it should all be the same. It's always the same pattern. You add the starter, you add the test starter. Even if the test starter is empty, we don't care. We created the test starter, which is empty, just add it. Okay? Maybe we put something in there in the future, just add it. We want to have always the same structure. And you can remove your dependency to Spring Boot Starter test, because every test starter now depends transitively on Spring Boot Starter test. We see that in the migration. Some examples. WebMVC. The starter is called starter WebMVC. And the starter for WebMVC test is called WebMVC test. Very creative. The WebFlux thingy is called WebFlux test. Guess what the security thingy is called? Security and security test, surprise, surprise. Okay, so it all follows like the same pattern. Okay? The technology name, then there is a starter for the technology and a starter for the test. All technologies now have a starter. Okay? Some dependencies didn't have a starter in 3.5. For example, Liquibase, Flyway, Kafka, and so on and so on. How those worked is essentially you put like Flyway core itself on the class path, and then autoconfigure detected it and autoconfigured itself. But now there is a starter. There is now a starter Flyway, a starter Kafka, and whatever. So every technology has a starter. The full list can be found in the migration guide. Star.spring.io is aware of that. So if you create a Spring Boot 4 project and put like Kafka or Flyway or whatever in the dependencies, it will put like the Kafka starter in there. If you are creating a Spring Boot library, please do not try to support Spring Boot 3 and Spring Boot 4 in the same artifact. It will be a lot of pain because we moved a lot of stuff. And then you have to do a lot of reflection hacks to get it done. Please don't do it. If you have support for Spring Boot 3, create a Spring Boot 3 support version of your library. If you support 3.4, please create a Spring Boot 4 library. We moved some internal classes. For example, Bootstrap registry is moved, the environment post-processor is moved, and all the other stuff. Okay. And if you update, please don't forget Spring Factory keys. If you don't know what Spring Factories are, good for you, but library authors will know. And because when we upgrade our libraries, it's easy to forget those because they are essentially string keys, and then stuff will not get found and stuff crashes. And yeah, Spring Factories. Okay, migration guide. How to do your actual migration. So this was all the like motivation for that stuff, how to actually migrate your application. Okay, the first thing you do is you add Spring Boot Starter Classic and Spring Boot Starter Test Classic. Those modules depend transitively on all the other modules we have. Okay, this is essentially our migration path to the smaller modules. So we add them first because they depend on everything, and then we are sure you have everything on your class path. Then you get your stuff to compile again by fixing the imports, because we changed all the package names, right? But we only changed the package names and not the class names. So you can always find it by getting your IDE to find the class, and then you just fix the import. Okay, now everything is compiling again, and your application starts up. Use the Spring Boot's properties migrator to fix the properties. The thing is not new, but use it. It will tell you there is an old property, upgrade to the new one. Then you're going to remove the Spring Boot Starter Classic and Spring Boot Starter Test Classic, because what you actually want is you want the smaller modules and not the one which depends on everything, because this doesn't solve the problem with the smaller jars. Okay? Now stuff starts to fail to compile. And now you add technology-specific starters and test starters, and the cool thing is now when the compilation fails, it will tell you, I can't find this class in this package, and because the package has a direct relation to the starter, you know which starter to include. Okay? Look at the imports if lost. So if it doesn't find, for example, something in the REST client package, you add Spring Boot Starter REST client. If it doesn't find something in the security package, you add Spring Boot Starter security. Right? That's the pattern. Some other stuff which have tripped up people, the Spring Boot Starter AOP is now called Spring Boot Starter Aspect J, because the technology is actually named Aspect J and not AOP. So we renamed this one. And this one will hit you too. Spring Boot Starter Web is now called Spring Boot Starter Web MVC. The Spring Boot Starter Web is still there, but we're going to remove it in the future. Because the technology is not called Spring Boot Web, it's called Spring Boot Web MVC, and we want consistency, so this thing is called Spring Boot Starter Web MVC. Okay? And the test starter is called -test. Something to look out. REST template is deprecated for removal. Okay? So we deprecated that in the past because we didn't want to add new features. Now we have deprecated it for removal, so it will be removed in the future. If you have REST template in your application, upgrade to REST client now. Spring Boot Starter Web MVC now only pulls in the stuff which you need to have Web MVC on the server. It does not pull in any auto configurations for clients. So if you do outbound calls, there is no auto configuration for it anymore and stuff starts breaking. And how to get it back? If you want to have the REST client, guess what you'll add? Spring Boot Starter REST client. And if you need the reactive web client, what you'll add is Spring Boot Starter Web Client. Okay? Just be prepared that you will have to add some starter to get your client arrangement working again. Okay, let's look at a real-world example. How do we migrate the pet clinic from 3.5 to 4.0? There are different ways to migrate. For our enterprise customers, there is Spring Application Advisor, which does that stuff. It uses custom open rewrite recipes under the hood. It has seamless CI/CD integration, so you can upgrade a lot of projects at once. And it's built by Tanzu, the team essentially behind Spring. Then there are also open rewrite recipes. I think there are commercial ones from Open Rewrite themselves, but there are also community recipes which you can use. You can also use your favorite LLM. Give it a try. Maybe it works, maybe it doesn't. And who knows? That's the fun with the non-predictability stuff. There's also an MCP server coming for Spring Application Advisor. So if you're using enterprise stuff, then you can point your LLM to this thingy, MCP, and then it does magic and then everything works. So I heard. Rachel talked about it in her talk. Or you do it by hand. And this is what I'm going to show you because I want you to actually learn how stuff works and not how to prompt the LLM until it works. Okay. So what we're going to do is we are first going to upgrade the Spring Boot version. Okay, it's 3.5, and we are going to upgrade it to 4.0. And then we run the build. And then stuff starts breaking. And it complains about, I could not find org test containers MySQL. Oh God, what is that? This is the old dependency, and this is test containers 1. And Spring Boot 4 pulls in test containers 2. And they took the opportunity, because every library, we really love major upgrades because we can break all the stuff, which is great. They essentially upgraded to the new module, just new artifact names. Okay, this is the only thing which you do. Just pull in here test containers in front of it, and it compiles again. Then we add the starter classic and the starter test classic. So we had this here, the Spring Boot starter test. This is no longer necessary. Replace it with Spring Boot starter test classic. Now it pulls in all kinds of stuff on your class path. Now you get it to compile again, and now you will see how we moved classes. Okay, stuff doesn't compile. The web package here is missing. What's happening? We have to fix the import. It's now this because it's the web MVC package. That's called org spring frame and boot web MVC. And now fix all the imports. And a lot of imports later, the stuff is running again. Then it complains there is a test rest template missing. What's that? Moritz, you have told me if I put on the starter test classic and stuff on the class pairs, everything is working. What's happening? And this is a bug. We have fixed it. I found that while working on the presentation. Fun, but it's not fixed in the next version. Just for reference, you don't need that when you upgrade to 4.06, which will come out next week. Then you're not affected by this bug. I was affected, just to warn you. If you're trying it right now, you will be affected by the same bug. In 4.06, it's fixed. You won't be affected anymore. But just for reference, the test rest test template is in Spring Boot Starter Web MVC test, and you can find that out by looking at the full package, which is not in the error message, but if you look at the full error message, which you get from your build tool, it's obvious that this thing is in Spring Boot Starter Web MVC test. Okay. Therefore, we add it to get it to compile again. Now, our application is running now. The tests are still failing, but our application is able to start up. Okay? So we do our boot run. We add the Spring Boot properties migrator, and we do a Gradle boot run again, and we watch for log messages, because this properties migrator essentially puts out warning log messages if it finds any properties which are deprecated. And it tells you what is the new one. So you do that, you watch for log messages. In our case, there are no log messages, so we can remove this thing again, because we only need it for the migration, throw it away again, and be happy. Now run the tests. The tests fail because there is a test rest template missing, but this time not on the compiler level, but on the Spring context level. So what's going on there? Spring Boot doesn't auto-configure test rest templates and test rest clients and stuff out of the box anymore. Okay? This is behind a new annotation, which is called auto-configure test rest template, which is in the Spring Web MVC test, I think. And just put that on your test, and the bean is there again. Now our test fails with some other weird error, which has nothing to do with Spring, but it's some other thingy. How to fix that? Okay, so the property migrator only looks at the properties inside your application properties or application YAML file, but not at the ones which you specify inside the Spring Boot test annotation. But if you use IntelliJ, for example, you get like those squiggly red lines, which usually indicate there is a problem. Okay? And there is also a problem because it's like strike through, which means it's deprecated. What you can do is you can hit Alt-Enter on this thingy and then click on the 3 dots here and then run the same inspection on the whole code base, and IntelliJ will find all the deprecated properties which you have used in test, and then you can fix them. And after we fix them, so what happened is essentially server.error.include message is not there anymore. It's now spring.web.error.include message. And if you replace all the properties in the tests, and this time it was only one, the tests are green too. Okay? Now the test passed and we can run the application. Okay, that's cool. Now we have to clean up, because what we actually want is we want the smaller modules, not the one which pulls in everything. We remove Spring Boot Starter Classic and Spring Boot Starter Test Classic. And then stuff starts failing again, because you can't compile, because stuff is missing from the class path. But now you see that this here gives you a cool error message, because org Spring Framework boot data JPA test autoconfigure does not exist. So what you add on the class path is Spring boot starter data JPA test. And you do that for all the stuff. Either you do it by incrementally compiling and looking at the package statements and fixing it, or what you can also do is you have a lot of starters already, just add the test starter for every starter you have, right? You have WebMVC, you add WebMVC test. You have data JPA, you add data JPA test. You have security, you add security test. And then usually stuff is fixed. Now the REST template builder is missing after we added everything. And this is actually in production code. Okay, so this is what I said. There is no auto-configuration anymore for the clients. So if you use a client, look at this package here and add Spring Boot Starter REST client. Okay, here. Spring Boot Starter REST client. Always let the imports guide you, and you will find the starter you will need. And after you've done that all, don't forget to add the test REST client test module. Okay, so every starter has a test module, just add it. Then your build is successful. All the tests pass, your application is upgraded Now you have to replace the deprecated starters. You take the Spring Boot Starter Web, replace it with Spring Boot Starter Web MVC. You're done. That's essentially it. Okay. Add the classic modules, get it to compile again, fix your tests, remove the classic thingy, put in the smaller ones, let you guide by the imports. Stuff is done. This is now upgraded on 405, all the tests pass, and you have like the small modules on the class pass. So your application is actually using the smaller jars and not the big ones. Cool. So this was the story how to upgrade your application, but there are other subtle bugs below the waters, which you can trip you up. We upgraded to Jackson 3, and Jackson 3 is like the next major of the Jackson framework, which does all the JSON stuff inside your application usually, since, I don't know, 15 years or so. I think Jürgen mentioned it in the keynote, how long ago Jackson 2 was released. And Jackson 3, of course, because it's a new major version, changes stuff. So, Spring Boot 4 and Spring Framework 7, we use Jackson 3. We introduce support for it. We are going to deprecate Jackson 2. Okay, so Jackson 2 will be going away. We also auto-configure by default Jackson 3. So if you create a Spring Boot 4 application, you get Jackson 3. Okay, you can get Jackson 2 back for a limited amount of time, but we really recommend Jackson 3. So what did they do in Jackson 3? They renamed all the packages, like we did. You see the pattern? Framework and library authors love this trick. It's now all in tools.jackson, okay? But the annotations aren't. So for example, at JSON name, JSON property and JSON creator and all the stuff, it's still in the old package. Okay? They tried to move it to the new package, but that was too much, so they changed it back to the old package. Okay, but everything else is under tools.jackson and not the com.fasterxml.jackson thing anymore. They also removed the object mapper. Okay, the object mapper before was the thing which you interact when you want to essentially marshal or demarshal your object into JSON or from JSON. And this was always mutable. So consumers of this object mapper could fiddle around, and then this stuff started changing globally JSON defaults, which is not that good. Now they have the immutable JSON mapper. Okay, so it's now called JSON mapper and not object mapper anymore. They also removed checked exceptions, so now they are using unchecked exceptions everywhere, so you don't have to catch the JSON processing exception and then, I don't know, wrap it in a runtime exception or whatever you do with that. And they updated default settings, and that's the fun part. Because the problem with this stuff is usually you use it to create JSON out of your DTOs. How many of you write tests to actually assert on the JSON and not on the, I call the controller and I let Spring MVC demarshal it, deserialize it into an object and then assert on the object which is returned. So you never see the JSON, right? So the JSON can subtly change and you don't know it. And that's the problem with those upgrades with Jackson 2 to Jackson 3. There could be subtle changes in the API and you don't know it because you usually don't assert on the plain text JSON stuff, but on like deserialized objects. And yeah. So, and this is API breaking stuff if you change if Jackson changes something in your JSON essentially. Okay, so the updated default setting, sort properties alphabetically is not true. Write dates as timestamps is false. So you get like ISO stuff inside strings and no longer this Unix epoch timestamp thingy which no one can read. And fail on trailing tokens is true by default. It also does the auto detection of modules. So Jackson has those modules, for example, for Kotlin, JSON parameters, date time stuff, and this is all now auto discovered. And you can control that if you don't want that with spring.jackson.find and add modules. This is the Spring Boot property to opt out. And more in the Jackson 3 migration guide. So they've written an extensive migration guide. If you really want to know what everything has changed, look at the Jackson 3 migration guide linked here. How to use Jackson 3 in Spring Boot. Instead of an object mapper, you now inject the JSON mapper. Okay, and then you can create JSON out of it. instead of the object mapper customizer, you use a JSON mapper builder customizer. Because a JSON mapper is now immutable, you have to use this builder thingy. Okay, you get the builder, you modify the builder, and then Spring Boot will create the immutable JSON mapper instance and inject it everywhere. Some properties have moved. So this is the old one. This is the new one, sorry. Those the old properties didn't have JSON in there. Okay, if you don't want to use Jackson 3, but you want to stay on Jackson 2, which I absolutely do not recommend, but you can do it, there is spring.jackson.use Jackson 2 defaults property. And this property, if you set this to true, Spring Boot will do its best to configure the JSON mapper in a way that it behaves like the object mapper in Jackson 2. Okay, so it's compatibility mode. But we can't promise that it covers everything, so test. It works without Jackson 2. Okay, so you get Jackson 2 behavior with Jackson 3. If you really want to have Jackson 2, there's dependency management for Jackson 2 still there. You can just depend on the com_XML Jackson database, for example. We still manage the version for you. And you can also use the object mapper alongside the new JSON mapper. So this is the Jackson 2, this is Jackson 3. You can mix them because they have different packages. All good. If you really want to have Jackson 2 auto configuration, there is a module, and this thing doesn't have a starter because we don't want to steer people to it. But if you really want to do it, you can do it. There is a Spring Boot Jackson 2 module, and there is the auto configuration for Jackson 2 inside it. But this stuff is deprecated, right? So we released a new module and deprecated it right away, which we normally don't do, but here it is. It's bold. And Node is written in uppercase letters because this stuff is going to go away, right? You have been warned. This configures an object mapper bean like Spring Boot 3.5 had, and then you can use it. You can use spring.jackson2 properties to configure all that stuff. You can use the old Jackson 2 object mapper builder customizer for customization. But other stuff inside the Spring portfolio might still use Jackson 3. For example, if you use Spring Web MVC, it uses Jackson 3 by default. And you now have to opt in so that Spring Web MVC uses Jackson 2. And there are a lot of properties for Web MVC, WebFlux, GraphQL, RSocket, and WebSocket, so that you can switch them to Jackson 2. But this is not possible for all Spring portfolio projects. For example, Spring Data or Spring HateOS, and I think Spring Data REST or whatever the thing is called. I think they are hard-coded to use Jackson 3, so it's not possible for other technologies. But there is a way to maybe ease the upgrade if you need more time to upgrade from Jackson 2 to Jackson 3. Everyone steamrolled already? There are 100 slides more to go. Okay, let's talk about Spring Retry. There was a talk from Jürgen about that already, resilience features in Spring Framework, so I'm going to just show it quickly. The Spring Retry project is in maintenance mode only, because all the features from Spring Retry have been integrated into Spring Framework itself. So instead of using Spring Retry, remove it, migrate to the Spring Framework thingy. You essentially put on a configuration class add enable resilient methods, which opts into this proxy stuff for retrying. And then you can annotate your methods with add retryable. And here you can see, for example, timeout 10 seconds, delay string 2 seconds, and some random jitter. And this stuff here, you can also use the Spring expression language to reference properties. Okay. Then there's JSpecify. Sebastian did a talk yesterday about all the null safety stuff. What is JSpecify doing? So Tony Hoare has invented the null reference. He called it the $1 billion mistake. And JSpecify is trying to fix it. Spring Framework had already nullable annotations. This was the org Spring Framework lang nullable. This is now deprecated. JSpecify is an industry collaboration to create another standard for nullness. There are a lot of big players in the industry, for example, Google, JetBrains, Meta, Microsoft, Oracle, Sonar, Square, Uber, and there's also Broadcom here. So thank you very much, Sebastian. Not sure if you're here for your work, what you've done on the JSpecify specification. And I know exactly what you're thinking. Why is there a 15 standard for nullness in Java, right? The thing is, the other standards were not that good, and now there's a 15th, a good one. Okay, so the main work is actually in the JSpecify specification. The JSpecify specification specifies how those nullable annotations should behave. If you look at the JSpecify jar, there are like 4 annotations in it, and that's it. It's 4 annotations. But the main work, which those people have been done on the working group, is essentially how to specify how those behave, so that tool vendors can now implement the specification, and the stuff behaves the same everywhere. The new annotations are type use. Like you can now also annotate generic stuff. So this list of nullable string denotes a list, which is not nullable itself, but it can store strings or null. Okay. 4 annotations: nullable, non-null, null-marked, and null-unmarked. Those are the 4 annotations. And now what we did is we hadn't add no nullable. So if you look at the Spring Boot code base, we never had nullable, nowhere. Like the Kotlin people were like upset about that, because if you interact with Spring Boot 3.5 from Kotlin, you always get platform type, stuff can be null, stuff cannot be null, have fun with the null pointer exceptions. Spring Boot now has full JSpecify support. Okay, so this is the patch we did. It's only 25,000 lines, so looks good to me. This patch file is actually like 6.8 megabytes in size or something like that. So we touched a lot of the code base. We went through all the stuff. We have null away, which does compile time checking of that stuff. So this is now like really checked with the type system. And we annotated like every API we have, and every internal stuff, and every test. Now we have like 9,000 something nullable annotations in the code base. Okay, those are the JSpecify nullable annotations. Kotlin automatically understands JSpecify, but if you use Java, this is also cool, because take a look at this thingy here. It's a Spring application run listener, and what we try to do is we hook into the fail thingy, and we want to log essentially, oh no, the name of the application failed to start, and a smiley which is just sad. Okay, can you spot the problem? There is a problem here. This will blow up in some cases, because the problem is, if you read the Java doc, it says this context here, it actually can be null if a failure occurred before the context has been actually created. And then it puts null here, you call get environment on null, and everything blows up, and your failure listener is now creating a new exception instead of logging, which is bad. If you upgrade to Spring Boot 4, you can see there is now an add nullable on it. So it's now annotated with nullable, so you know that it's null, and stuff which is not annotated is never null. And now IntelliJ warns you that if you invoke get environment on this stuff, it may produce a null pointer exception. Maybe you should do something about that. And the same for Kotlin, because we have nullable on there, the type which you get here is no longer a platform type, which can be null or cannot be null. It's guaranteed to be nullable. So there is this question mark, and then you can't do context.environment, because this here can't be executed. This is not null safe, so you need to have the Kotlin Elvis operator or null safe call operator, whatever the thing is called. Okay? So now Kotlin forces you on compile time to deal with the null pointer exception. And you can have the same with Java, but you have to add another plugin. If you're interested in that, I recommend watching Sebastian's talk about JSpecify, where he went into that in detail. And now we have null safety portfolio white. Okay, Spring Boot, Spring Framework, Spring Data, all the other Spring Boot project, all the other Spring projects, they are now all annotated with add null, so you know if there is no add nullable on it, it can't be null. If there is add nullable on it, it can be null, and you should deal with it. Okay, new features. HTTP service client. Not sure if you know that one. Maybe you know OpenFane. This is essentially you write an interface, and Spring does behind the covers create a client for you. So you annotate it with add get exchange. You can use variables here. Then you do import HTTP service clients. You point it to the interface, which you just created. You give the group a name. The group is used for properties, and then you configure it. For example, you can set the timeouts, you can set the read timeouts, and you set the base URL, and then you can inject this thingy here. Okay, this is the interface, which has no implementation written by you, but Spring Framework will create at runtime a thing which does HTTP calls behind the covers. Okay, it's really cool because now you have like easy way to call other services. And the cool thing is, because this is an interface, you can super easily mock it inside your unit tests. You don't have to fiddle around with mocking REST template builders and stuff. You can just directly mock the unit test. We also have API versioning. This is also very cool. So you have a controller. This is the 1.0 version of it. This is the 2.0 version of it. This is the 3.0. And if you look here, there is a plus. So it's 3.0 version or better. And now callers can specify which version of the API they actually want to invoke, which is great. If you have like strong backward compatibility for your API, you can do it now with built-in Spring features. Here, then you have properties inside boot. So you can say this is the default version is 1.0. So if the client doesn't say which version it wants to have, we always invoke the version 1.0. We're going to use the X version header. You can also do query parameters and other stuff. And then we say, okay, version 1, 2, 3, and 4 is supported. And if the client sends a different version, it just gets a 400-bit request. And we can see that here. So if I invoke it without the version, it invokes 1.0, 1.0 explicitly, it invokes 2.0, it invokes 3.0, it invokes 4 is mapped to 3 because it's 3.1 plus. And if you try 5, it fails with a 400 because we specify here that 5 is no valid version. Right? This is API versioning, which is now supported inside Spring Boot via properties. Okay. Then we have the REST test client. The REST test client is, it has been in Spring Framework since, I think, last version, but we never had auto-configuration in boot for it. So if you wanted to use the REST test client, you always had to write some boilerplate code to essentially get the REST test client. But now we have the add auto-configure REST test client, and then you can inject it inside your test method, and then you can use REST test client.get, point it to something. This is automatically configured to point to your web server, which is started by Spring Boot test. And then you can do expect body is equals to with a much better API than the old REST test template had. It also has an assert J matcher, which is like really cool. So it's the same, but here you essentially get the response back, get the response, and then you have this assert that, and this plugs into the assert J infrastructure, and now you have like this cool fluent API assert that response has status okay, the body text is equal to something, which is, I think, a very nice pattern to actually test your REST controllers and stuff like that. So don't use test REST template or other stuff anymore. I would recommend to migrate to the REST test client because it has a very nice API to actually assert on stuff. Okay, some other miscellaneous changes, grab bag of stuff. The liveness and readiness probes are now enabled by default. Before that, they were automatically enabled if, for example, Spring Boot detects that it runs in a Kubernetes environment, but now they are enabled by default like everywhere. Mockbean and SpyBean are gone. They have been already deprecated since 3.4, but now they are removed. Use Mockito Bean or Mockito SpyBean instead, and it looks like that. You essentially put add Mockito Bean on a field. It Spring Framework behind the scenes creates a mock for it, put it in the context with a higher priority than your existing my service, and then the mock is injected everywhere. Then you can here program this mock, and then here you can use the mock or use any component which got the mock injected, and then you have nice unit tests. Optional Maven dependencies are no longer included in the Uber jar. So if you like optional dependencies and you want them in Uber jar, you have to opt in. You configure include optional on the Spring Boot Maven plugin. If you don't do that, we just leave them out. Okay, so for example, I think Lombok is declared as optional by default when you create it from startspring.io. So Lombok is no longer in the jar and stuff like that. And smaller changes. The Mockito test execution listener is gone. We deprecated it, but a lot of people miss that because it's hard to detect. If you want to use like add mock fields and stuff like that, please use Mockito extension from Mockito itself with JUnit 5 and stuff is essentially the same. Yes, so those were my like 500 slides of the Spring Boot test migration. Scan this code if you want to download the slides. Very good, I see a lot of mobile phones. and then you can use the slides for reference. So I'm sorry that I put that much text on the slides. Normally I don't use that, but normally I don't do that, but for reference, just now you have it if you want to migrate. Everyone scanned the thing already? If not, come to me afterwards. So wait, there's more. There was like 500 slides more, okay? Literature for all the stuff, like we have a migration guide, we have release notes, Jackson has a migration guide, we have a blog post series about other stuff, because this wasn't everything which we did, because this like covers Spring Boot and not all of it, because what I've not covered is this, and this, and this. Because I only have like 50 minutes, maybe I should have submitted an 8-hour workshop, but that's how it is. So there is more stuff in the migration guide, so please read that migration guide and go through it. But I think the modularization changes which we did is the most difficult ones to navigate, and I hope I gave you some guidance about how to navigate that. So now, thank you very much.